Imagine a journey to the stars. Not just a short trip through the familiar confines of our solar system, but an interstellar adventure that takes us beyond the limits of our understanding. A journey to Proxima Centauri, the closest star system to us, a little over 4.2 light-years away. To make this leap, we have to travel across unimaginable distances, roughly 37.8 trillion kilometers, which might sound impossible. Today, our fastest spacecraft would take tens of thousands of years to make the journey. Yet, despite this, the dream of reaching distant worlds like Proxima B, the closest known exoplanet, is not just a fantasy, it's something scientists are already working to make possible. Could we one day journey to another star system? How could we bridge the enormous distance that lies between us and distant exoplanets? It's an ambitious question, and the answer could be closer than you think. To understand how interstellar travel could work, we must first consider just how far away these star systems are. A light-year is the distance that light travels in 1 year, roughly 9.46 trillion kilometers. To put that into context, the nearest star system to our Sun, Proxima Centauri, is located about 4.2 light-years away. That's more than 37 trillion kilometers. With current technology, even the fastest spacecraft, such as the Voyager probes, would take tens of thousands of years to reach Proxima Centauri, let alone Proxima B, which orbits the star. The Voyager probes, launched in 1977, have been traveling through space for nearly 50 years. Yet, they are still thousands of years away from reaching even the closest neighboring star system. The vastness of space makes it difficult to even imagine a future where we can visit another star, but that hasn't stopped scientists from trying to find a way. Despite the enormous distances involved, some scientists are optimistic that interstellar travel is within our reach. The first step toward making this dream a reality is understanding why these distances matter and what obstacles we would need to overcome to travel to a planet like Proxima B. Proxima B has long fascinated astronomers because it sits within the habitable zone of its star, Proxima Centauri. This is the region where temperatures could allow for liquid water to exist, a crucial factor for life as we know it. The planet is roughly Earth-sized and orbits its parent star every 11.2 Earth days, making it an interesting candidate for the search for extraterrestrial life. However, while Proxima B is intriguing, it's not a perfect twin of Earth. For one, the star it orbits is a red dwarf, a type of star that is smaller and cooler than our Sun. Red dwarfs like Proxima Centauri are known to be volatile, emitting powerful flares that could harm a planet's atmosphere and potentially make it inhospitable. Proxima B also experiences tidal locking, meaning one side of the planet always faces its star, while the other side remains in permanent darkness. This could lead to extreme temperature differences between the two hemispheres, creating an environment that is more hostile than it might seem at first glance. Even so, Proxima B remains one of the most exciting exoplanets discovered so far, and it's not the only one. Over 6,900 exoplanets have been discovered orbiting stars beyond our solar system, and many of them are potentially habitable. For example, there's the planet Tau Ceti, located just 12 light-years away, which has a very similar size and location in its star's habitable zone. But Proxima B holds a unique position in our quest for knowledge about the universe, as it's the closest potentially habitable planet to Earth. And so, the question remains, could we, someday, send a probe or even a human mission to explore this distant world? The obstacles standing in the way of interstellar travel are enormous. While the idea of sending humans to distant planets is one that has captured the imagination of generations, current technology simply isn't up to the task. The fastest spacecraft we have today, like the Voyager probes, are incapable of reaching even the nearest star in any reasonable time frame. So, how can we overcome these challenges? The answer may lie in new propulsion technologies, ones that are still in the realm of theoretical physics but are slowly becoming more practical. One of the most promising ideas comes from a concept known as light sail propulsion. Light sails are incredibly thin, reflective sails that can be propelled by light, either from a laser or from the sun. The concept dates back to the 1970s when physicist Robert Forward first proposed using light pressure to accelerate a spacecraft. The idea is simple: a spacecraft with a large, reflective sail could harness the power of light to push it forward, gradually increasing its speed. Over time, a light sail spacecraft could theoretically reach a significant fraction of the speed of light, making interstellar travel possible within human lifetimes. The problem, of course, is how to achieve that. The laser system required to propel a light sail spacecraft would need to be incredibly powerful. To reach Proxima B in just 20 years, a spacecraft would need to travel at speeds of up to 20% of the speed of light, or roughly 60,000 kilometers per second. To accelerate a tiny spacecraft to those speeds, a massive laser array would be required, one capable of producing an enormous amount of energy. In 2016, the Breakthrough Starshot initiative was launched, aiming to develop this technology. The plan involves using a network of ground-based lasers to propel a tiny spacecraft, no larger than a microprocessor, with a light sail attached to it. Once accelerated to speeds of up to 20% of the speed of light, the spacecraft would sail across the cosmos toward Proxima Centauri. Breakthrough Starshot is still in its infancy, but the concept has captured the imagination of scientists and engineers around the world. The spacecraft would weigh almost nothing, just a few grams, so it would be able to withstand the intense acceleration forces of the laser beams. The challenge, however, is in developing the technology needed to create such a powerful laser system. The laser beams would have to be focused on the tiny spacecraft from millions of kilometers away, which means that the laser array would need to be incredibly precise and incredibly powerful. Moreover, these spacecraft would need to be protected from the harsh conditions of space, including cosmic radiation, high speeds, and potential collisions with micrometeoroids. The Breakthrough Starshot mission, while ambitious, could dramatically change the way we think about space travel. While it is focused on sending tiny probes to distant star systems, it could lay the groundwork for more advanced interstellar missions in the future. If successful, it would show that it is possible to reach other star systems in a matter of decades, rather than centuries or millennia. But the road to interstellar travel doesn't stop with the light sail. There are other concepts that could make travel to stars like Proxima Centauri a reality. One alternative approach is to use traditional chemical rockets in combination with advanced propulsion systems, such as ion drives or nuclear fusion. These technologies could enable spacecraft to reach much higher speeds than current systems, though they still fall short of the kinds of speeds required for interstellar travel. Ion drives, which use electrical energy to accelerate ions and create thrust, have already been successfully tested on spacecraft like NASA's Dawn mission. While ion propulsion is incredibly efficient, it still doesn't offer the kind of speed necessary to make interstellar travel feasible in the near future. Another possibility lies in nuclear fusion, which powers the sun. If we could harness the energy of nuclear fusion in a spacecraft, it could provide the immense thrust needed to reach other star systems. However, nuclear fusion technology is still in the experimental stages, and building a spacecraft capable of utilizing fusion power remains a distant dream. Nonetheless, there are other methods of propulsion being explored by scientists, and each breakthrough brings us one step closer to turning the idea of interstellar travel into a reality. The challenges of interstellar travel are immense, but they are not insurmountable. To overcome these obstacles, scientists and engineers must continue pushing the boundaries of what is possible. With the development of advanced propulsion systems, lightweight spacecraft materials, and innovative power sources, humanity may one day send probes to other star systems and unlock the mysteries of distant exoplanets like Proxima B. While we may not be able to travel to the stars just yet, the progress being made today is laying the groundwork for future generations to explore the cosmos in ways that we can only begin to imagine. So, what can we conclude from all this? Well, the dream of interstellar travel is no longer confined to the realm of science fiction. While we may be many years away from actually visiting Proxima Centauri or other star systems, the groundwork is being laid today. The Breakthrough Starshot project and other similar initiatives represent the first steps toward a future where humanity can explore the stars. With the rapid pace of technological advancements and the continued dedication of scientists and engineers, interstellar travel may one day become a reality. It might take decades, or even centuries, but the journey to the stars is no longer an impossibility, it's an exciting possibility, and we are already on the path to making it happen. If we can continue making progress on technologies like light sails, nuclear fusion, and other futuristic propulsion systems, the dream of interstellar travel might not be as far off as we think. One thing is certain, humanity's desire to explore the unknown is unyielding, and that curiosity will likely drive us to achieve the unimaginable. The stars are calling, and the journey has already begun.